Here is new Ruby and net ID is ZN236. I'm doing question 8 in homework 7. Okay, let's start. It's a Poisson process. And the first question, we need the expected value of xt. Okay, and we will know we know that the probability is this, and as before, we know Poisson distribution. We have this property. And we use derivative method. We can get this. This is the expected value we calculated before in chapter 4. And here we have the probability with lambda t. And xt equals to n 0 t. It's a number of call in this interval. So we can get the expected value of xt equals to lambda t. You can see here and here the difference. And in the first question, in fact, we can get other two value. The expected value of x squared t. We can find it use the method we used before. From this formula, we can get use the same method, the derivative method. So this is equals to 1 plus lambda times lambda. So here the expected value of x squared t is 1 plus lambda t times lambda t. And the covariance it equals to expected value of square minus because we have got two values, we can get the result is lambda t. Okay, Then the second question, if we need to calculate the auto correlation T1 T2. Here we know that in fact T1 T2 we need to know which is bigger, so we will use two situations. The first is T2 is greater than T1, and here we will know x T1 equals to x T1 minus x0. This is from 0 to T1, the number of core in this interval, because we have this relationship. And x T2 minus x T1. This is in interval from T1 to T2, cos in. These two have no overlapping part, so they are independent. With this knowledge, we can solve this problem. T1 T2, we write it as definition. T1 x T2. Here we will use some trick. Okay, and then we can divide it into two parts, because these two things are independent, so x T1 times x T2 minus x T1, they can become two expected value, and I will write it down. Okay, this is the first part. The second part is x T1 times x T1 plus x squared T1, the expected value. Okay, and from above we have no the value of the two part. So we just bring the value into this formula. Okay. Lambda t1, lambda t2 minus lambda t1 plus 1 plus lambda t1, lambda t1. And the result is lambda t1 plus lambda t1 t2. Okay. And here we assume t2 is greater than t1. The second situation, t2 is less than t1. In fact, it just change t1, exchange t1 and t2. The result is lambda minus lambda times t2 plus lambda t1 t2. So in conclusion, we can write our t1 t2 equals to lambda minus t1 t2 minimum t1 t2 plus lambda t1 t2. So we get the odd correlation. Thanks for watching.